A mole is a specific quantity of a substance. Just like if you had a dozen eggs, that would mean that you had 12 eggs. Or if you have a gross of something, that means you have 144 of those items. A mole is a specific quantity just like a dozen or a gross. Only instead of having only 12 items, or even only 144 items, for a mole you have 6.022 times 10 to the 23rd particles. Particles can refer to atoms, ions, molecules, or occasionally we would just generally use the term particles, but more often we're referring to atoms, ions, or moles. And when you write the number 6.022 times 10 to the 23rd, you need to specify what you're talking about. So you should never just have 6.022 times 10 to the 23rd for something. It should be 6.022 times 10 to the 23rd atoms, 6.022 times 10 to the 23rd ions, 6.022 times 10 to the 23rd molecules, but there should be a unit following that. So 1 mole is also known as Avogadro's number, so you will see that term as well. More specifically, the standard unit, or the standard definition for a mole, is that a mole is Avogadro's number of atoms in exactly 12 grams of carbon-12. So carbon-12 here refers to the isotope of carbon that has 6 protons and 6 neutrons. So it's not the weighted average, it's not the average atomic mass, but it's the specific isotope. So, that's all well and good, but we can't exactly count out 6.022 times 10 to the 23rd atoms. That would take us probably longer than we have possibly in our lifetimes. So, we're obviously not going to be able to count it out, and our balances don't weigh things in moles, so how exactly will we measure out a mole of something? Well, we have a convenient way of doing that if we look at the periodic table. So if you look at the number that's written under an element on the periodic table, that is the atomic weight of the element. That's also the mass of one atom in AMU. So 1 atom of silver will weigh 107.87 AMU. But conveniently enough for us, this is also the mass of 1 mole of atoms in grams. So if I have 1 mole of silver, that means that that mole of silver weighs 107.87 grams. And I can use this convenient fact as a conversion factor. So if I wanted to go between moles of silver and grams of silver, I can express this as 107.87 grams of silver per 1 mole of silver, or I can write 1 mole of silver per 107.87 grams of silver. So I could write it either way depending on whether I'm trying to convert from moles to grams or grams to moles. So remember, look at everything as a conversion factor. The molar mass of something is in units of grams per mole, so we can use that to get from grams to moles or moles to grams. Let's look at a few examples here. Let's calculate the molar mass of a few of these, and then we're going to convert from 0.4 moles of each substance into grams. So if we take carbon monoxide, if we look at the periodic table, carbon has a molar mass of 12.01 grams per mole. And oxygen, if you look up the molar mass of oxygen, it comes out to 16 grams per mole. So if we add that together, we get 28.01 grams per mole. So carbon monoxide has a molar mass of 28.01 grams per mole. Now what about calcium oxide? Let's try calcium oxide. Calcium, if we look that up on the periodic table, has a molar mass of 40.08 grams per mole. And oxygen has a molar mass of 16 grams per mole. So if we add that together, we get 56.08 grams per mole. Let's try sucrose here. So if we have sucrose, we know that carbon has a molar mass of 12.01 grams per mole. And in this case, there are 11 of them, so we have to multiply that by 11. Hydrogen has a molar mass of 1.01 grams per mole, and there are 12 of them. And there are 22 of them. And oxygen has a molar mass of 16 grams per mole, and there are 11 of them. So if we add all of that up, we should come up with 330.33 grams per mole. And the last one, we have sulfuric acid. So sulfuric acid has the formula H2SO4. So hydrogen has a molar mass of 1.01 grams per mole, and there are 2 of them. Sulfur has a molar mass of 32.06 grams per mole, and oxygen has a molar mass of 16 grams per mole, and there are 4 of them. So if we add all of that together, we come up with a molar mass of 98.09 grams per mole. So let's try converting these from 0.4 moles of each of these substances into grams. So if we start with carbon monoxide, if we have 0.4 grams of carbon monoxide, we said that carbon monoxide had a molar mass of 28.01 grams per mole. So, since we have moles to start with, moles needs to go on the bottom of the next step. And we put the 28.01 grams on the top. Now, when you're doing these, don't just write moles or grams. Write the substance with moles or with grams. So this is moles of carbon monoxide and grams of carbon monoxide. You need to specify moles or grams of what, because when we get to conversions where we're going from one substance to another, it gets very confusing very quickly if you don't know moles or grams of what, because you're going to have 2 different moles and 2 different grams or more than 2 in some cases, depending on your conversion. So moles cancels with moles on the bottom, and we're left with grams of carbon monoxide. So if you put into your calculator 0.4 moles of carbon monoxide, or 0.4 times 28.01, you should come up with 11.20 grams of carbon monoxide. Okay, let's try another one here. If we do calcium oxide, we have 0.4 moles and the molar mass of calcium oxide was 56.08 grams of calcium oxide per mole. So again, moles of calcium oxide cancels with moles of calcium oxide. If you multiply 0.4 times 56.08, and be putting these into your calculator and make sure that you get the same answer I did. If you multiply this out, you should come up with 22.43 grams per mole. Now I'm going to let you try the last two. Set those up the same way you did these first two here, and see what you come up with for an answer. For sucrose, you should come up with 132.13 grams. And for sulfuric acid, you should come up that 0.4 moles has a mass of 39.24 grams of sulfuric acid. So let's try a few more examples here. How many moles of calcium atoms are present in 20 grams of calcium? So if we start with 20 grams of calcium, and we have 20.0, so we don't want to lose any significant figures here. So if you look up on the periodic table, the molar mass of calcium is 40.08 grams per mole. Since we start with grams in this case, grams needs to go on the bottom of the next step in order to cancel out grams. So the molar mass always goes with grams, and the molar mass is always for 1 mole of a substance. So it will always be how many ever grams from the periodic table per 1 mole of a substance. So if we divide 20.0 by 40.08, when we're determining how many significant figures to use, we go by how many significant figures we were given in the problem. We don't use the significant figures from the molar mass. That's something that we get from the periodic table, and we chose to round off to the hundredths place. So we're going to have 3 significant figures, so this comes out to 0.499 grams of calcium. Now let's try one where we need to go the other direction. We have 3.40 moles of N2, and N2 means that we have 2 nitrogen, so we need to multiply the molar mass of nitrogen by 2. So if we look up the molar mass of nitrogen, it's 14.01 grams per mole. If we multiply that by 2, it comes out to 28.02 grams of N2. So if you put into your calculator 3.40 times 28.02, that comes out to 95.3 grams of N2. Okay, let's look at one more example here. We have 58.4 grams of chalk, which is calcium carbonate. And we want to know how many moles that is. So look up on your periodic table the molar mass of calcium, carbon, and oxygen, and calculate the molar mass of calcium carbonate. So you should come up with 100.09 grams of calcium carbonate per mole. So then we're going to take 58.4 divided by 100.09, and you should get 0.583 grams of calcium carbonate. Now let's look at one where we need to go from moles to molecules. So we said earlier that 1 mole of a substance contains 6.022 times 10 to the 23rd molecules. So if we have 5.32 moles of calcium carbonate, remember we can use anything as a conversion factor. So in this case we're going to use the fact that 1 mole is equal to 6.022 times 10 to the 23rd molecules as a conversion factor to get from moles to molecules. So 1 mole of calcium carbonate contains 6.022 times 10 to the 23rd molecules of calcium. Running out of room here. Now when you type this into your calculator, do not type times 10. Find the E button on your calculator. It will usually be EE or EXP. And use that button. So if you type into your calculator 5.32 times 6.022 times 10 to the 23rd, we find out that we have 3.20 times 10 to the 24th molecules of calcium carbonate. So let's try one more here. This time we're going to go from grams to molecules. So if we start with 5.32 grams of calcium carbonate. Now we calculated a few slides ago what the molar mass of calcium carbonate was. We said that that was 100.09 grams per mole. So since we start with grams, we need grams on the bottom of the next step in order for the grams to cancel out. Per mole of calcium carbonate. And then 1 mole of calcium carbonate has 6.022 times 10 to the 23rd molecules, and I'm kind of running out of space here, so I'm going to have to cram this in. So grams cancels with grams, moles cancels with moles, and if you put into your calculator 5.32 times 6.022 times 10 to the 23rd and divide that by 100.09, what you should come up with is that there are 3.20 times 10 to the 22nd molecules of calcium carbonate in 5.32 grams of chalk. So we're going to wrap up here and we'll get some more practice with this in class.